I welcome you to this lecture on Process Control, Chapter 2, Laplace Transform, Part 14. So in this, we are going to find the inverse Laplace transform of a function. And this function and its inverse Laplace transform will be useful in the study of process dynamics. So this is the function 1 by tau 1s plus 1 into tau 2s plus 1. We will find the inverse Laplace transform of this function by the method we'll use here is we'll split this by partial fraction and then find the inverse transform. So that will be the easier method. That will be the easier method. So let us split this into partial fraction. So let us write this as a by tau 1s plus 1 plus b by tau 2s plus 1. So let us find out the constants a and b. So if you multiply with the LCM, then it must be equal to a into tau 2s plus 1 plus b into tau 1s plus 1. Now what do we substitute? So let us substitute first. Put s equal to minus 1 by tau 1. So if you put s equal to minus 1 by tau 1, this term becomes 0, second term, because tau 1s plus 1 then becomes 0. So you get 1 equal to a into minus tau 2 by tau 1 plus 1 that is equal to a into tau 1 minus tau 2 by tau 1 . So if you solve for a is tau 1 by tau 1 minus tau 2. Okay, now let us substitute s equal to minus 1 by tau 2. So if you do this, the first term, this becomes 0 here, this term, when you put s equal to minus 1 by tau 2, this becomes 0. So you are left with only this. So you will get 1 equal to b into minus tau 1 by tau 2 minus plus 1, that is equal to tau 2 minus tau 1 by tau 2 into b. So if you solve for b, b is going to be tau 2 by tau 2 minus tau 1, or I can also write this as minus tau 2 by tau 1 minus tau 2. So this is a and b, b here and a here. Now let me substitute this a and b in the function, this function here, and write. I have substituted a and b in this equation. Okay, I just taken a and b, one denominator tau 1 minus tau 2 is common, so I taken tau 1 minus tau 2 common, and a is tau 1 by tau 1 s plus 1. B is minus tau 2 by tau 2 s plus 1. Now let us take the inverse of this. What is the inverse of this? So let us invert this function. I will write this as 1 by tau 1 minus tau 2 into I'll divide the numerator and denominator by tau 1. So this becomes 1 by s plus 1 by tau 1. Here I will divide numerator and denominator by tau 2. So it is 1 by s plus 1 by tau 2. Now it is easier for me to take L inverse Laplace. Now let us take invert Laplace transform. So if you take inverse Laplace f of t equal to 1 by tau 1 minus tau 2, and what is the inverse of this? Is 1 by s plus a form. So it is e power minus, where a is 1 by tau 1. So the inverse of this is e power minus at, that is here e power minus t by tau 1 minus, the inverse of this is e power minus t by tau 2. That's all. So this is the required inverse of the given function. This is a required inverse of the given function. So I written the same thing again here. So this is f of t. So this and this are same. F of t here is the required inverse Laplace transform of the given function this. So this function, as I said, will be useful when you study the dynamic response of some processes in process dynamics. So I hope it is clear. The next lectures will come with more functions for whom we will find the inverse Laplace transform. So stand by till then. Bye. I hope you understood. Please subscribe to the channel and share it to your friends. So when you subscribe, you will get notified of the upcoming lectures. See you.